let's take a look at where we left off yesterday. Now, in my notes, just going to go with the lights off for a sec, okay? I have another example of the try-catch block and the file reader and the print writer and all the other Java classes that we use to write code to file. There is an example of this code in my notes that you can take a look at. But we did our own example yesterday, which I think was a little bit more robust than the one in the notes. But it essentially will read data from files and write data to files. Okay? The one in the notes uses simple input-output boxes, which is fine. But we're going to take it up another notch today. Okay? Hi.
Sorry, I'm in media production, and I'm doing a documentary, I guess, in this class.
Yeah, just one sec. Hang on one sec. Okay, so back to where we were. This is another class I want to introduce to you. We're going to use this in the example today. Another class that's in the Java I/O library is called the file class. And the file class has a bunch of built-in methods that are also good for interacting with files. So I'm just going to show you a couple of them right now, and we'll do a few more in the example. So it has a constructor for building a file. You can build a constructor with a path or with a directory and a file name, which is essentially the path pieced together. There are methods within the file class to do things like, and we're going to use this one today, get the absolute path. The absolute path returns the first, middle, and last name of a file. There's also methods called getName, which produces only part of the file name. So you can see here it's producing the middle and last name of the file. Okay? Then there's one called getParent. And what does getParent give you right here? If this is the full name, and this is the middle and last name, what does parent give you? The first name. Okay? You can use a method called exists to determine whether the file actually exists, because sometimes you're trying to manipulate files that don't actually yet exist on a system. You can get the length of the file in bytes. This is something you see in Microsoft Windows. It shows you how big the file is. So it tells you how many, for example, kilobytes a file is. Well, you can do that now in your code using that built-in method length that's built into the file class. There is a one that can actually return all the names of all the files in a directory. Okay? Believe it or not, directories or folders are files themselves. And I just want to just mention that real briefly. Like, we're used to this kind of system. You have your C drive, then you have a folder that's called like My Documents. And inside there, maybe you have your essay and a picture of your cat, etc. Okay? So this is the kind of picture that Windows gives you or a Mac gives you. But in reality, this is a file as well. That's actually a file. It's a file that's tracking the contents within here, but it's essentially the way the system organizes things. And it's organized into this system, and I'm not just writing this just because it's me. It's called the File Allocation Table, okay? Or the FAT, okay? The FAT, the File Allocation Table, tracks the files. That's what the F stands for. Allocation means where they are stored in memory. To allocate something means to put it in memory. And table is basically how it keeps it organized. But we don't want to see that as users. As users, we just want it organized in a system that looks very visual. The folder system was used because that's the way it was done before computers. You think about file cabinets with folders. So the users got more used to that. By seeing that, they kind of understood a little bit better rather than have some complicated table of data. They presented it to the users in a way they understood. But even directories are files. And that's why when I was mentioning that here, when you get a list, the file itself could be the name of the directory. Like this could be My Documents. So when it gives you a list back, it gives you the list of all files within that directory. You can also get timestamps out of this. Like when was the last time this file was modified? And again, you'll see that in stuff like Microsoft Windows. It shows you that date stamp as well. You can rename files. So the file class gives the ability to rename one file to another name. And it also gives the ability to delete files. Now, think about that for 1 second, some of these built-in methods. You can now rename files that already exist. You can delete files that already exist. You can get a list of all files within a directory. You could potentially write a piece of code right now that could go through, with a loop, every single file on a computer system and rename it something like walks rules, or delete them all. So there's potential using files here to cause a lot of damage to the computer system itself in terms of its file structure, its file allocation table, which is why, again, we have things like try-catch blocks to create sort of a safer environment there. Okay? Now, Java recognizes this. When you write a Java application, a Java app, it allows you to do this. It allows you to go through and rename files and stuff. However, you may recall way back that I also said Java can write what are called applets. Applets are Java programs that run on web pages. Applets cannot access files. And think about why not. If you embedded a Java applet into a web page, and then that web page could potentially rename files, that would just mean by going on the internet, you could potentially cause a virus to hit your system. Well, that is not allowed. So Java does have some security built into this file handling system. Okay? Okay. The last thing I want to do, and we're going to do this in our example, is there's another class I want to try to use called the JFileChooser class. Now notice it starts with a capital J. This is very similar to the class JOptionPane in the sense that it will produce a user-friendly dialog for programmers to use, specifically to choose files. And that's the part of our program that's missing. We can't actually, when we hit save, we don't ask the user where they're going to save it. So what we're going to use is a more graphical version of this called the JFileChooser, and it's going to look like this. It's going to have that similar look to programs that you're used to, like Microsoft Word and stuff like that. It has a slight sort of Java look to it, but it'll allow us to actually save our data to specific files. Okay? So let's do that in our example right now. Okay, so over to NetBeans, and we're going to look at this method that we wrote early on called getFileName. And we wrote in some temporary code to make it work. Well, I want you to get that code out of there. I want you to delete that code. And I want you to rename the parameter. The parameter of this method is whether or not we should be saving a file or opening a file. So I'm going to rename this parameter option. Which option have I chose? Okay, whoops. Okay, so our method called getFileName will have a parameter now called option that will be whether or not we're saving or opening a file. Okay, let's put the code in. There's not that much code to write in here. So we will start by creating something called the JFileChooser. And I suggest using Control Spacebar to bring it up. Once you use Control Spacebar, it should import this to the top of your code. Notice the number of imports we have up top now. We have buffered reader, file writer, IO exception, that's for errors, print writer, and now the JFileChooser. Most of these come from the java.io package, which is the input-output package. But FileChooser comes from the Swing library, the same place where JOptionPane comes from, and JInputDialog and stuff like that. Okay, so JFileChooser chooser equals a new JFileChooser. And this one does have the ability to create, it has what's called a default constructor. Okay? So we can construct a JFileChooser with empty brackets there. We don't have to give it any parameters. So we build this chooser object. Okay. Now, what's going to happen, I'm just going to show you real quick, is it's going to, and again, don't type this code. I'm just going to put return null for now, which will at least stop the method. Is we're going to say chooser.show and it has 3 options for the dialogues it can show. The generic one is just called dialogue. That one's not very useful to you. And then it has specifically an open dialogue and a save dialogue. So it actually has these built in. So for example, if I just say save dialogue here, okay, again, don't put that code in there, but I just want to show you what happens now when I run our program. Now when I run our program, this dialogue appears, okay? So this is the dialogue that we're calling up now from that library. It's a nice dialogue for specifically saving and opening, is it creates that nice ability to save our poem to a specific directory, okay? Whereas before we just manually typed in the code, this is going to give us that nice ability to do that. Okay, but what happens is, once the user selects a directory and types in a name, we need to return some results. So I'm going to make an integer called result equal to 0, and then I'm going to start a do-while loop. Okay? So we have a result equal to 0, and I've started a do-while loop. Inside the do-while loop, I'm going to have an if statement. If option, the option which is the parameter up here, if the option dot equals the word open, so if they've sent me the word open in my option, then I'm going to say chooser dot show open dialog. And inside there I'll put the word null. If we were working with a JFrame, a GUI JFrame, I could put the name of the JFrame there to parent my JOption pane, or sorry, my JFile chooser to that object, but we're not doing that, so we're just going to put null there. And then I'm just going to use an else. If I don't want an open dialog, I'm going to say chooser.show save dialog, because it's one or the other. It's the open dialog or the save dialog. Okay, now we need something to control our loop. And the way we control our loop is with this thing result. Well, result is not equal to chooser dot, or sorry, I'm sorry, not chooser. We actually have to, sorry, my fault. We have to use the result. So we have to say result equals chooser.show dialog. So what comes back from the show dialog is a result. And as long as the result is not jFileChooser dot approve, okay. Okay, so let me try and explain what's going on here. So we have this integer called result. That's the result of what happens after the user has used that dialog box. We will either show the open dialog or the save dialog. It doesn't matter. One of those two dialogues will appear, and the user has to select a file or type in the name of a file if they're saving, right? So they type in a name, they select a directory where it's going to be saved. Once they click OK or save or open on those dialogues, it will return a result. The result is actually a number. It's like whether or not it was successful in saving. But basically what I've done is I've forced the loop here that says the user's going to keep getting that dialog box unless they hit the approve option. And the approve is either save or open. That's the approve. So in other words, if they hit cancel, this box should pop up again. So we're kind of forcing the user to save and open properly. So that's what that loop is being used for right now. It's not the only way you could do this. You don't have to use a loop to do this. I'm just doing it just to show off some of the features. Now, at the end of that loop, we create what's called a file object. So we're going to make a file called file. Now this will require you to click on the light bulb and add the import for this. It generally doesn't add it automatically. You generally have to use the light bulb to do this. So now we have one more import up top here, the file class, which is in java.io. So we have all these classes imported now into our code. So now that we have the file, we say file equals chooser dot get selected file. So what that did is it pulled out of the chooser object, the dialog box, the file that the user selected. And they either selected it for opening or they selected it by typing in the name of it when they saved it. Now we have this stored as a file object. It doesn't come back as a string object. It comes back as a file object. Now what we need to do is turn it into a string object. So we can do that right here at the very end with the return statement. We can say file dot, and as I said before, there are several different methods for getting the name of the file built into the file class. Here are some of them, okay? So there's get path, get parent, get name, get canonical path. All of those break up different parts of the file name. Some of them get the first name and the last name. Some of them get, the first name only. Some of them get the middle and last name, etc. But the one we want that gets all of it, first, middle, and last, is the very first one. Get absolute path, which should get totally the path to the file. So I want you to use that one, get absolute path. And that should be it. That will be our get file name program. So I want to show you how it runs. I'm going to run this, click play. Notice how right now it's saying, where do I want to save this? So I'm going to select, for example, the desktop. And I'm going to put a file there. I'm just going to call it poem dot, and believe it or not, the last name of this file doesn't really matter. I'm going to put JPEG, which seems weird. JPG, and I'm going to hit save. Notice now it goes directly to an open dialog. So I'm going to go back to the desktop. There's poem.jpg right there. And I'm going to hit open. And sure enough, it opened it and displayed it on the screen like I predicted. Even though sitting on my desktop right now is what Windows thinks is a picture file. Windows thinks poem.jpg is a picture file. If I try and actually open it in Windows, it won't, because it says, well, it doesn't appear to be a JPEG file. But my program doesn't care. It just thinks it's a text file and opens it as a text file, which is exactly what I told the code to do. Okay? So a lot of data files are just very simple, and how they're interpreted by the program is what works. Now, they're not all text files. I don't want to make you think that. They are not all text files. But a lot of them are. Okay, so this now completes our example. We have 3 methods within our class called file handler. Getting a file name, saving a string array to a file, and opening a file. Hopefully these 3 methods will be stuff that you could reuse in different programs that you try to undertake. I have one more quick thing to talk about. The presentation, by the way, is basically over as well. Right here at the end, it just has another example in my presentation of how to use the JFile chooser, which we just did. So basically, I just want to, for a second, go back to where we started. So we started here by identifying that files are not as simple as you'd think, that they are actually broken up into parts, and that those parts are stored in something called the file allocation table. Okay? We then talked about how files work with classes to stream data to different objects. Streaming to things like the screen is one thing, but now we are streaming our data to files. And we're doing that through manipulating different classes. We drew this really rough diagram of how that would work with the objects and the fact that it was contained within an error trap. But I actually drew up a better diagram for this. Okay? Well, I didn't draw it, but here it is. Okay? So here's your user interface where you're working. And your user interface is obviously working with code. And over here is the place you're going to save data, persistent storage, whether that's a USB or a hard drive or whatever. It's some storage device. In the middle is our try-catch block that creates an error trap around these various objects. So around objects like the JFile chooser and the file class and the file writer, print writer, file reader, and buffered reader. And the way it passes data between those objects, passing it in the form of strings or as file objects or other types of data, okay? This might be another way to look at it as well. This is kind of a summary of some of this stuff, right? So let's read some of this. So here you can see some of the methods built within these classes, okay? So that the file object has constructors and get methods, delete methods and stuff like that. The JFile chooser has the show save and show open dialog, and it has the get selected file method. The buffered reader, the file reader, and stuff like that. These are essentially the classes that we used, these 6 classes, to actually manipulate files. So we use these classes in combination with your code. Okay?